Hi, my project LeMusic is a music player controlled by hand gestures. This means, in addition to the common keyboard I/O, you can use hand gestures to control the volume, pause a song, shuffle, or seek. For instance, just swipe your hand right to pass on to the next song. You can even virtually grab and throw songs at the player to play them. This is LeMusic's pipeline. At the beginning, hand activity is tracked by Leap Motion Controller. It tracks key features of your hand, such as each of your fingers' location. In the middle stage, I use this primitive tracking information to construct recognition filters. At the final stage, the information is consumed by the music player. For example, if you move your closed fist up, this is a play signal, so the player responds by simply playing the song. As a new feature, I added the feedback loop that asks for a confirmation before executing. For example, if you move two hands away from each other, the system is going to ask you to show a thumbs up sign to turn on the shuffle functionality. LeMusic is applicable to multiple domains. So I created two different interfaces with almost the same engine. The first is a standalone version which would be your default player. The second is a DJ version with two separate players with two giant discs which you can scratch with your finger to have that DJ feeling. It is also really fun to throw your songs on. Since the Implementation Studio, I added the feedback loop feature that I described for the gestures and disc scratching for the DJ version. I also tuned some recognition parameters following user study. Let's see a real-time demo.
Play the song.
Hi everyone, so this is the plain version that I'm starting to interact with. So I move my fist up to play the song. And I move my fist down to pause it. And play it again. Using my index finger, I control the volume. Of course, I can also control the volume by simply interacting with it. To switch to the next song, I simply slide my hand. So this is the next song. And this is the next song. And one important feature is the feedback loop. So let me show you the feedback loop. So I initiate the shuffling process by moving two of my hands close to each other.
If you wish to turn shuffle on, show me a thumbs up. Shuffle activated.
So as soon as it... So here what happened is I moved two of my hands away from each other to turn on the loop for activating shuffle mode, and it asked me to show the thumbs up sign to turn the shuffling mode on, which I did, and then it turned on the shuffling mode. So let's see if shuffle worked. See, the next song it's not following the original order, so the shuffle mode is on. Alright, so let me go to the switch to the DJ version. And this is the scratching mode in effect. I control the right player if my hand shows to the right side of the screen. And now, let me show you the song grabbing mode. And to hear the scratching effect again, you can hear that it's going at a much faster rate. Or this song. And I turned the song grabbing mode off by showing the thumbs down sign. That's pretty much it for the DJ version. So what worked well? Leap's primitive tracking information made it a breeze to define more complex filters so that I didn't bother with statistical methods. I also saw that following the user study, the system welcomed intuitive interaction and recognized with high accuracy. And what didn't work well? Interestingly, the Leap hand tracking dropped down in performance when exposed to direct sunlight. I also saw that the Leap device occasionally outright froze or crashed. System also occasionally reported false positives. For future work, LeMusic's two different versions could be combined through a simple mechanism such as with the help of a button, to transition between the versions. Also, the DJ version could be expanded by adding more music editing features. Most importantly, I learned that I should once go again with the Occam's razor principle. I started with Leap's simple assumptions, primitive tracking information to create filters rather than use statistical methods which are hard to debug. I also learned that the users are happier if their interactions are intuitive or natural. Finally, I'm happy that I started with an initial goal of delivering a system that does a core job and then incrementally adding all these interesting features to it.